Okay, in this video, we want to talk about the definite integral as signed area. In previous videos, we mainly talked about the fact that if you have a function whose graph is given like this blue curve, then the area between the blue curve and the x-axis, that's the definite integral. In particular, we're going to look between a and b. We're going to look at this area, and another expression for that area is the integral from a to b of f of t dt. So if this is given by a formula, you might be able to use your calculator to compute it, or you might estimate it using Riemann sums, any number of things. Now, what we want to focus on now is that in fact some situations it's not a positive area that's represented by this definite integral, but rather a negative area. What do I mean by that? Well, let's look at a function which is negative. So here now the blue curve lies below the x-axis, and if I want to find the area between the x-axis and f of t, I can still use the definite integral. But because the heights of the little rectangles that we use to approximate this integral, the heights are now negative because they're below the x-axis, this area is the negative of the integral from a to b f of t dt. Or in other words, another way to think about it is that the integral, in this particular case, integral from a to b f of t dt, is equal to minus area. It's negative area. So for example, if this area is 5, then the actual, the area all under here and between f of t and the x-axis, then the actual integral is going to be minus 5. Okay, so it's something to keep in mind. Anytime you're below the axis, the area counts negatively. So let's look at a mixed situation. Here's a situation where I have part of the time the graph of f is above the x-axis and sometimes it's below the x-axis. And now I want to understand what is the integral from a to b of f of t dt. Well, that's the area between a and b, but during this time between a and this point, I'm above the x-axis, so I count this area positively. And then after this point, I start dipping below, and so this part is counted negatively. So for example, if this is an area of 4, and this has an area, this orange area is 3, then the actual integral is plus 4 for the minus 3, which is 1. So there's some cancellation here. Let's do another example. Given the graph of f below, compute the integral from a to c of f of x dx. This is something you might see in your exercises. So I have a, b, and c, and f of x is this blue curve. And I'm told that the area here is 8, and the area above the x-axis is 5. So by what we discussed before, I should take the positive area, which is the 5, and then I subtract off the negative area, which is 8. So altogether I get the definite integral is minus 3.